Hello, welcome back. Today we're going to be talking about diagnosis and troubleshooting automatic transmissions, focusing on the General Motors 6L transmission family. What we're going to do is take you through the fundamentals of transmission theory and concept of operations, introduce you to some key diagnostic tools and techniques, and then we'll walk through a couple of examples. So this will be the first in a multi-part series. How many videos I'm going to shoot, I'm not exactly sure. It'll largely depend on how long it takes me to get through all the different material and subject matter I want to present. So let's go ahead and get started. So one of my favorite techniques for communicating otherwise complex and difficult subject matter to an audience that may or may not be very familiar with it is to use analogies. So in this case, we're going to be comparing an automatic transmission, analogizing it to something that we are fairly familiar with, at least at a high level, and that's the human body. So that'll help us understand the anatomy of a transmission, all the internal subsystems and components, and how they work together to allow the transmission to do its job. So we'll start off with the brain. All people have a brain, not all people use their brains, but the brain is the command and control center for all of our voluntary and involuntary bodily functions. In a transmission, the valve body and or TECM, in the case of these transmissions, performs that same exact function. So TECM stands for Transmission Electronic Hydraulic Control Module. And for all more modern units, they will work in concert with a valve body or valve bodies to drive and govern all functionality within the transmission. So in this case, we have the TECM, you have the internal mode switch, and then the valve body assembly itself, and then underneath there's a wiring harness and speed sensors. So we'll get much deeper into the valve body and TECM in subsequent videos, but for now, we will consider that the brain of the transmission. So, like human beings, transmissions also have a heart, and the heart for them is the front pump assembly. So, in the 6L80, half of the pump body is integral to the bell housing. The other half of the pump is the pump cover. So, pump's responsible for generating line pressure and circulating fluid throughout the unit so that all the other parts and systems can work as designed. Okay, moving backward from the heart, aka front pump, the transmission has its own equivalent of a skeletal structure, fibrous muscle tissue, and connective tissue that perform very similar roles for the transmission that our skeleton, fibrous muscle tissue, and ligaments and joints play for us. So, from a skeletal point of view, what does a skeleton do for humans? It gives us structure, it differentiates us from invertebrates, and allows us to ultimately manipulate and change the world and environment around us. For the transmission, it performs a very similar role in that it absorbs and channels engine power out to the drive shaft and ultimately to the rear wheels. So the transmission skeletal system consists of its input and output shaft, its gear train, and any hubs and drums that might also be involved in channeling and ultimately transmitting engine power to the rear wheels. Now, when it comes to fibrous muscle tissue in a human being, our muscles animate our bones. It allows us to move and become dynamic. In other words, move and change at different rates of speed and ultimately change our energy states. So fibrous muscle tissue equivalent of transmission would be your clutch packs and your bands, along with your apply pistons, steel plates, and either pressure or backing plates, because all of those components work together to, when applied, change the rate of rotation on the hub, the drum, or the gear component that they are meshed or mated to. So when you change the rate of rotation of all the different parts inside a transmission that rotate, you are changing the rate of spin that the output shaft, which everything's ultimately connected to, is rotating relative to the engine. So that gives you your different gear ratios, and when the transmission shifts, it shifts into different gears. So without fibrous muscle tissue, aka clutch packs, that would not be possible. From a ligaments and tendons perspective in the human being, they pair our bones with our joints. So all of the one-way clutch assemblies and transmissions perform a somewhat analogous task in that they join various fibrous muscle tissue components and their corresponding skeletal structures to the rest of the frame. So in this transmission, there's only one one-way clutch, and that's the low sprag, and it pairs the low reverse clutch pack and joins it with the rear planetary assembly, ring gear, and ultimately the output shaft. So it plays an integral role in changing the rate of spin of that output shaft based on what other elements are being applied, and that's of course based on what the brain is telling the transmission to do, or the rest of the body, the transmission to do. The largest organ in the human body is our skin. The skin is basically our container, and obviously the analogous equivalent to that in the transmission would be the case, and for the torque converter would be the bell housing, and then of course your extension housing, or transfer case adapter. So that's a down and dirty, very hasty overview of the inner workings of a transmission and how it functions and how all the different parts and subsystems act to give the transmission the ability to shift and change its gears based on what the driver is doing with the vehicle. So now we'll get into some troubleshooting and diagnostic tactics, techniques, and procedures, and introduce you to a tool known as a range reference chart, so that you can use that tool in conjunction with things like scan tools and multimeters and other equipment to pinpoint the source of the trouble that you may be having with your transmission. All right, so here we have a range reference chart, and again, sometimes it's referred to as an application chart or a range chart, like I have it here in various manuals, books, or whatever. But this is an incredibly powerful tool to help you pinpoint, or at least narrow down, the particular components or parts within the transmission that may be causing your drivability symptoms. So let me just kind of walk through the chart itself. This way you have an understanding of how to use it, and what all the different columns and sections mean, and then we'll get into the rest of the case, kind of using the range reference chart to help us pinpoint particular trouble areas based on like a scenario or two that we'll run through when it comes to diagnosing drivability symptoms. So on the left side of the chart you have two main columns, and those columns are range and gear. So range is based on what you select in your column shifter, and it's defined as either park, reverse, neutral, drive, manual 2, or manual low, or manual 1. And then you have each corresponding gear that's associated with that range. So every range has at least one gear. In the case of park, reverse, and neutral, there's only one gear per range. And then in the case of drive, you have all your forward pattern gears, so first, second, third, fourth, fifth, and sixth. And then each of the manual ranges have their own respective gears. So manual 2, obviously that's manual second gear, and so is the same for manual low. Now, across the rest of the column headers on the top, I have all the individual components, starting with the electrical components and kind of wrapping with the applied elements and one-way clutch. And then I also have the gear ratios there for reference as well. On the bottom, I have what I'll refer to as either the location or locus of control for each group of components. And starting on the left side, you have the IMS, or internal mode switch. That's the part that's directly responsible for communicating the range selected through to the TECM and the PCM. And we'll dive deep into the IMS, talk through how it works, how it functions, and take you through the process of diagnosing and bench testing it with the multimeter in the next video. But suffice to say that it governs range and range selection in the transmission as far as communicating that to the TECM and the engine control module. For your gears, you have all of your command and control solenoids. So you have your shift solenoids, your clutch pressure control solenoids, your torque converter clutch solenoid, and your main line pressure control solenoid. All of those are in the TECM. We'll continue on, further right, you have all your case applied elements. So your 1, 2, 3, 4 clutch, your 3, 5R clutch, your 4, 5, 6 clutch, 2, 6 clutch, and low reverse clutch. And then the next column is the one-way clutch. So this chart is intended to tell you what is working, i.e. on or off, or in the case of the applied elements, what is applied, where in the case of the one-way clutch, when it is holding based on a given range and gear combination. Okay, one last thing I'll point out about the range chart and the information therein has to do with the clutch pressure control solenoids and what they're doing when they're energized, because that's not consistent. In most transmissions, when a solenoid is energized, it is considered to be on, and when it's considered to be on, it's making pressure, or, generating pressure. In the case of these transmissions, that varies based on what solenoid you're talking about. So
we'll start with the 1, 2, 3, 4 clutch pressure control solenoid, which is solenoid number 5, and the 2, 6 clutch pressure control solenoid, which is solenoid number 4. Yeah, I know, it makes perfect sense, right? So when these solenoids are being energized and commanded on, they are generating pressure. So when you're in drive first gear, CPC number 5 is generating pressure because it's turned on. And it's turned on so that it can apply the 1, 2, 3, 4 clutch. Conversely, the 3-5R clutch pressure control solenoid and the 4-5-6 clutch pressure control solenoids 2 and 3 respectively, again, perfectly intuitive, right? When they are commanded on, when they are energized, they are not generating pressure. Okay, so it's important to know that when you're using that portion of the range chart to diagnose potential problems or shifting issues to transmission. The TCC solenoid is available in all gears starting with second gear, and so it's designed to come on to lock the converter when you're in each of those respective gears other than first gear. And then lastly, the line pressure control solenoid is infinitely variable or continuously variable based on input of various sensors that are feeding data to the TECM and to the ECM, and that's largely based on what the driver is doing with the vehicle in terms of acceleration or percentage of throttle and or braking and all that good stuff. So that is the range chart. So now we'll frame the rest of the discussion around how we could use this chart as a tool in either by itself in in isolation or as part and parcel of a whole diagnostic workup using scan tools and multimeters and other tooling to narrow down and ultimately determine the causes of our drivability symptoms.
Alright, so in this example we have a situation where somebody gets into their 6L80 equipped vehicle. Maybe they're going to work in the morning or whatever. They get in, start it up, throw it in drive, and it moves forward for a few seconds or so and then immediately neutralizes. So driver throws it into manual 1 and same thing, neutral condition, no movement whatsoever. So now in a panic, the driver throws it into reverse, and much to the surprise of the driver, reverse actually works. It engages strong, vehicle moves backwards under its own power without any issue whatsoever. So driver parks it back into the driveway and gets out, and the first thing that he or she does is look at a range reference chart to try and narrow down the list of suspects and figure out what failed and ultimately try to get an idea of what it's going to cost to fix. So, recalling from our discussion on transmission anatomy and relating it to that of a human being, we know that at least broadly speaking, we have several points of failure here to consider. So we have the brain, the heart, the skeleton, fibrous muscle tissue or connective tissue, all are on the list of suspects, right? So the first thing we want to do is look at our range chart, because that's going to help us narrow down that list and vector onto a likely root cause of the failure. So let's think about what's in play here. We have reverse, we have drive, and we have manual low. Okay, we know from our background that transmission was recently serviced, fluid was changed, filter was changed, and let's just assume that owner did it himself or herself. And when the pan was dropped, fluid looked normal. Didn't smell burnt. There was nothing remarkable in the pan. No burnt clutch material or anything like that. So, with that all in mind, and the fact that we know reverse works, let's go through this chart and see if we can methodically figure out where the problem actually is, where the breakdown happened. All right. So first thing we want to do is look at drive 1. Right? No movement in first. We know that it moved for a couple of seconds, but that's it. So first we'll look at the shift solenoids. Shift solenoid 1 and shift solenoid 2 are both on. Now we know reverse works, so let's take a look and see what's going on in reverse. Shift solenoid 1's on, but 2 is off. So if this was a shift solenoid problem, chances are we would have not had reverse, or we would have, experienced something that would tell us that something's wrong in reverse as well, in addition to drive. And because that did not happen, and because from our background we know no diagnostic trouble codes were generated or stored as a result of this breakdown, it's not likely we have a problem with shift solenoids. And in the same vein, we'll compare reverse and drive for all of our clutch pressure control solenoids, and we see there's a marked difference between what is on in drive as well as manual low compared to what is on and off in reverse. And we see a whole slew of solenoids off in reverse. In fact, every single one of them are off. In drive, every single one of them are on except for the 2/6 clutch. So we can then further deduce that more than likely we don't have a solenoid problem. And again, the lack of trouble codes here, further bolsters that suspicion. So line pressure, we know that the line pressure control solenoid's working because, again, we have reverse. If the line PC was malfunctioning, we would either have no movement or we would have very erratic movement, slippage, or some other potential symptom. So that leaves us with our applied elements. So, again, here we have our skeleton, our fibrous muscle tissue, our connective tissue. Let's take a look and see what's going on in drive 1. The 1, 2, 3, 4 clutch is applied. That means it's working. 3-5R, 4-5-6, and 2-6 are all at rest. The low reverse clutch is working, and the low sprag is holding. Okay, so those are the three elements in play in drive. Now we compare that to reverse, and we see the 3-5R clutch is working in reverse. We also have the low reverse clutch applying, and nothing else. So the sprag, freewheels, and no other clutch packs are working. So again, we can eliminate the low reverse clutch as a source of the problem straight away because it works in reverse. If that was the problem, we would have no reverse either. Taking a look at the 1, 2, 3, 4 clutch, we know that this is a problem in these transmissions. However, the fact that we observed no burnt clutch material in the pan, the fluid smelled clean, did not smell burnt either, and typically when the 1, 2, 3, 4 piston cracks, you'll experience some level of slippage before you have a total loss of movement in first gear. And, we didn't experience that in this scenario. This was, kind of all of a sudden. So preponderance of the evidence suggests that the 1, 2, 3, 4 clutch is fine. It is not the source of our problem. So that only leaves the one-way clutch, the low sprag assembly. Now, before we go any further, I will mention that there are other causes within the valve body that can result in a no movement condition or neutral condition in drive and manual low. The most common problem that folks will see or experience is a number 1 check ball getting stuck in the separator plate. When that happens, all the drive oil that's supposed to go to the 1, 2, 3, 4 clutch and apply it, gets dammed up. Nothing gets to the clutch and it doesn't apply. So, knowing that, given the overall context and understanding the scenario, we can further surmise that the valve body is not likely the cause. And the reason I'm saying that is because of one detail, and that is the fact that the vehicle did move under its own power very briefly, like a couple of seconds, 2-3 seconds, but it did move before it neutralized. In a case of a stuck check ball, it's not going to move at all. It's either stuck or it's not. And as soon as it sticks, you have no movement. And the likelihood of it sticking at the very earliest stages of your drive cycle, when everything's cold, is not very likely. It usually happens during other parts of the drive cycle. It doesn't usually happen when you first start up and attempt to drive the vehicle. So for now, we're going to discount that as a possibility just for the sake of the exercise, and we're going to focus on that low one-way clutch. So let's take a look at what actually happens to achieve first gear at the area of the one-way clutch. Alright, so we have all the anatomical components of the transmission that are directly involved in the achievement, if you will, of first gear, or responsible for producing first gear in the area of the one-way clutch, the low sprag. So what happens here is you have your sprag assembly. Okay? The sprag is such that it freewheels counterclockwise and it locks clockwise when it's splined on to its location here on the back side of the center support. Okay, this is the area of the low reverse clutch. So you have your blind spline here. This is that wide spline that interconnects or meshes with the corresponding blind spline here on the stator of the center support. So I'll just put that on. Now, I'm missing a few components here. All right, we don't have an apply piston. We have our frictions, but we don't have our steels or our backing plate. But no matter. The piston, the frictions, the steels, and the backing plate are all equivalent to our fibrous muscle tissue here in low reverse. Okay, that's the low reverse muscle, if you will. This is our connective tissue. This is our ligament and or our joint connecting the low reverse clutch pack to the skeletal structure, which is our center support, our rear planetary carrier assembly, and our output shaft and ring gear. Now there's no ring gear in here, but you know, same principle. Let's assume it is. So you have your frictions and your steels, and they're all meshed and, you know, with the sprag, enveloping the sprag. Okay, I'm not going to put the other two in. So this clutch pack envelops the sprag, and when the low reverse clutch is applied, it holds the sprag in place. Okay, holds it in a fixed position. Now remember, the sprag freewheels. So when the sprag is working, it is actually holding in concert with the low reverse clutch pack and the 1, 2, 3, 4 clutch pack. All of those elements together, though, that fibrous muscle tissue and that connective tissue, join with the skeletal structure. Okay, so this is the skeletal structure, and that skeletal structure then works to give us our output energy. Okay, and that output energy is delivered by the output shaft. Okay, so let's look at the stack up. Here's our planet. Our planet is going to mesh with the lugs on the outer race, and then we have our output shaft. Now again, we have our ring gear and then we have our hubs, but for the purposes of this example or this scenario, you know, they don't matter. Basically, all of these parts in here, ligaments, fibrous muscle tissue, skeleton, all combine to provide that dynamic energy or transfer that dynamic energy that was ultimately provided by the engine out to the driveline and the wheels. So in first gear, this output shaft is spinning one time for every 4 rotations of the engine. Okay, when that sprag fails, okay, it is no longer able to spin. It just sits in neutral. So I guess it's kind of like this. So that is the anatomy of a breakdown at the low sprag assembly. All right, so we showed you how we use the range reference chart, as well as a kind of hands-on demonstration of the gear and clutch components working with the low roller to give us first gear. Now let's look at another scenario that involves the 3.5R clutch and the hubs, and we can see how they all work together to achieve third gear. So we'll begin that scenario now. In our previous example, we looked at a situation where we had a failure of connective tissue equivalent inside the transmission, so namely the low sprag. In this example, we're going to look at the beginnings of failure breakdown in fibrous muscle tissue equivalent, specifically the 3.5R clutch. So in this scenario, we have somebody with an earlier model 6L80E equipped vehicle, let's just say 2007 or 2008, and They, again, same kind of scenario. Maybe you're taking off running errands or going to work. They drive the vehicle. First gear's normal. Take off, nothing unusual. The shift from first to second is also perfectly fine. Same RPM, same engines, same road speed, and the shift quality and feel is identical to what it has always been. So when I get to the 2-3 shift, driver thinks that there was a slight slip or a flare, very subtle, but it seemed like it was there, like there was something abnormal about the 2-3 shift. So pays close attention throughout the rest of the drive cycle on the way to the shopping mall, let's just say, and driver noticed it one more time, a little bit more pronounced this time. Okay, we'll assume here that gears 4, 5, and 6 were normal, and that reverse also works perfectly fine. So I think in the background we noted that the vehicle is relatively well maintained. It's not used in any kind of high performance application, just simply a daily driver commuter, and that no diagnostic trouble codes were yet stored. So let's take a look at the chart and see if we can quickly isolate the source of the problem, and then we'll kind of walk through the mechanics of the breakdown so that you understand what parts of the anatomy within the transmission are at play when it comes to delivering third gear, and what a slip actually looks like when we're working it through from a parts and systems perspective. Okay, so first thing we're going to do is we're going to come to our range drive and our gear 3, so drive 3, and we're going to see what components are involved, whether either being on or energized or applied and or working. So for third gear, we see that shift solenoid number 1 and shift solenoid number 2 are off and on respectively. We also note that shift solenoid number 1 is on in first gear and then comes off in second, while shift solenoid 2 is on in first, second, third, and pretty much the rest of the way throughout the forward pattern range. So the fact that shift solenoid number 1 is on and then comes off tells us that if there was a problem with shift solenoid number 1, we would know about it before we got to third gear. Same with shift solenoid number 2. It's on, or at least it's supposed to be on, through the entirety of the forward pattern range for drive as well as manual. So again, if we had a problem with shift solenoid 2, we would have known about it. And furthermore, more than likely, not always, but more than likely, a failure in one of these two solenoids would have generated a diagnostic trouble code. There are exceptional scenarios where they won't, and I'll discuss those later once we get to the Techum, but for now, let's just go with what is the norm and assume that there are no issues with shift solenoids number 1 and 2 for the reasons stated. So now let's take a look at our clutch pressure control solenoids. So we have 4 of those, the 1, 2, 3, 4 CPC, that's number 5, the 2, 6 CPC, that's number 4, and we see that for third gear, 1, 2, 3, 4 is on, and the 2, 6 clutch pressure control solenoid is off. So for solenoid 5 and 4, on means energized, means producing pressure, so what we're seeing makes sense for third gear, and furthermore, the 2-6 clutch pressure control solenoid is off initially, then it has to come on for second gear, and then it has to come off again for third. Okay, likewise, the 1, 2, 3, 4 clutch pressure control solenoid has to come off for fifth gear, and so because we were able to achieve all of our forward pattern gears within drive, we can assume that there's no issues with those two solenoids. Now, for the 3.5R clutch and 4.5.6 clutch pressure control solenoids, when they're off, they're producing pressure. So we see that in third gear, 3.5R clutch pressure control solenoid is off, it's producing pressure, and then it comes on, shutting the pressure off for fourth gear, and then it's off again in fifth, turning pressure back on. Okay, so the fact that, again, same deal, we have all of our gears, I don't believe that there would be any reason to suspect a problem with that clutch pressure control solenoid. And likewise for the 4.5.6, it is off in fourth, fifth, and sixth gear and on in all other gears, 1, 2, and 3. That means that it is functioning normally. So our TCC is available in all gears except for first, and well, park, neutral, and reverse as well. And then our line pressure control solenoid is on in all gears and we have no reason to suspect any problems with either of those two solenoids because, again, the shifting was normal other than at the 2-3 shift. So now that leaves us with applied elements. So again, we're looking at D3. We see that the 1, 2, 3, 4 clutch is applied and the 3, 5 arc clutch is applied. So 1, 2, 3, 4 clutch has not given us any issues. If there was a problem with that clutch, like let's just say the piston was cracking or starting to fail, we would have noticed some slippage in first gear. It might have been subtle at first and then gotten progressively worse. In this case, we don't detect any of that. There's no indication that that clutch is compromised. So that only leaves the 3, 5 arc clutch. Nothing else is applied or working in third gear when it comes to our applied elements, and our low sprag is freewheeling, so it's not doing anything either. So we can conclude with a very, very high degree of certainty that there's something up with the 3, 5 arc clutch. Now again, I'll interject real quick and talk about the valve body. The 3, 5 and reverse clutch boost valve and clutch regulator valves are a source of trouble as well. And again, for this purpose of this scenario, we're going to discount or rule them out just, again, for the sake of the scenario. Now, when we get into the valve body and we start talking about Techum and we do bench testing and valve body testing, we will revisit in detail, in very granular detail, all of the different valve trains, the role they play in achieving shifts and controlling the transmission, and talk through all of the different failure modes, if you will, that are attributed directly to the valve body. Then the scenarios will get a lot more complex because we're bringing the valve body into the equation. For now, we're going to keep it simple, stick to the fundamentals so that you can take this knowledge base and start building up upon it. So anyway, let's take a look at the mechanics of the beginnings of a breakdown or failure in the 3, 5 arc clutch. Okay, so on the bench we have all of the components that are integral in the delivery chain for third gear. So when we say delivery chain, we are talking about every single component or part inside the transmission that is responsible for providing a given gear. Now, here we're just looking at case components. Like I said, we're going to keep it simple. We're excluding the valve body, and just by virtue of our scenario and a review of the chart, we can exclude the Techum also. And the internal mode switch doesn't figure into anything. In the speed sensors, we can assume they're working because, again, we were able to shift. So first you have your 3, 5 arc clutch drum. Okay, this drum contains the 1, 2, 3, 4 clutch and the 3, 5 arc clutch. Okay, now when you're looking at the transmission horizontally, and let's just say this is the front, it is this side here, the base of the drum, that faces forward, and it is these welds that love to leak, especially in early models. In 2010 they reinforced these welds from the factory so that the incidence of leaking was much, much less prevalent than it was prior to 2010, but you still had leaks, like I still see them, but just not anywhere near as common and not anywhere near as bad. Okay, like this particular drum is leaking like a sieve, and I'll do a separate video to show you what that looks like. But anyway, know that our 1, 2, 3, 4 clutch is on and our 3, 5 arc clutch is on. So now we have to build up the entire skeletal and musculature structure so that we can understand exactly what's happening inside the transmission and know where the power flow is being interrupted that is resulting or causing the transmission to slip. Okay? Because a slip is by definition a sudden uncontrolled gear ratio change that is either temporary or, in the case of a neutral condition, permanent. So right now we're experiencing a very subtle temporary uncontrolled gear ratio change between second and third gear. Alright, so when you're assembling the transmission, you're going to have your 3/5R drum, you're going to have your input shaft slash input carrier ring gear, and your 4/5/6 clutch. So the 4/5/6 clutch goes here, and then your input planet and sun gear goes right here. Okay. Now just a quick word of caution, because most GM planetary carriers, the way they're installed when the transmission is vertical on the bench is this side generally faces up. Alright, now if you installed it like this in the 6L transmissions, Okay, it'll go in there, but what'll happen is you'll have no movement in any gear whatsoever. No movement in drive, no movement in manual, no movement in reverse. And the reason for that is you will have broken the link between the 3/5R clutch drum, which of course has your forward gears and your clutch essential for reverse, with the rest of the skeletal structure, aka gear train and hubs and everything else. So the reason you will have broken that bond is because these splines here, okay, these splines mesh with the splines here on the inside of the drum. So you want to make sure, sorry about that, you want to make sure that these splines and this part of the planet is facing up, okay, when you're assembling this on the bench. Okay, and we'll put our sun gear. Now the sun gear splines mate with the splines on the pump stator. So you got the male splines on the pump stator and the female splines here on the sun gear. Now sun gear, you can put that in any old way, it doesn't matter. Alright, so let's mate what we refer to, and I'll kind of refer to this here, this whole structure, at least from a skeletal point of view, as the cervical spine. This is the upper part of the spinal column that, like I said, if this link is broken between the drum and the planet, maybe gear train failure up here, or because it's installed backwards on overhaul, you will have no movement in any gear whatsoever, and the transmission and consequently vehicle will be paralyzed. And that's what happens when you break your neck. So let's go and carefully mate these. And yes, I know there is a thrust washer and a bearing, and no, I don't have it on the bench. No big deal. Okay. Alright, so now we have the cervical spine assembled. So before we assemble the rest of it, we need to understand the relationship between what's going on in this drum and also this drum to what is going on with the components rearward of that drum. So you have your 3 hubs. This is your 456 clutch hub. Okay, it's not going to do anything in this scenario because we're not really concerned about anything beyond 3rd gear. But these splines mesh with the splines here in the stationary portion of the planetary carrier assembly. Okay, so that's really the only relevant tidbit that I'll point out when it comes to the 456 clutch hub and clutch pack. So you have your 1, 2, 3, 4 clutch hub. Okay, these lugs here are grabbed when the 1, 2, 3, 4 clutch applies. So when you're in neutral, and I'll try to spline this on and see if I can mesh it. Okay, it's not meshed all the way, but again, it doesn't matter. When the vehicle's in neutral, the clutch pack is not working, and the clutch hub is spinning independently of the 1, 2, 3, 4 clutch. Once you put the vehicle into drive, then the 1, 2, 3, 4 clutch pack grabs the 1, 2, 3, 4 clutch hub, and the two begin to spin in sync with each other. Okay, so here's neutral. They're kind of rotating, but they're not really in sync. And then here is application of that clutch. Okay, now that synchronization changes the rate of rotation in every other component rearward of that hub. So the hub splines into the lower sun gear on the rear planet, which of course is meshed with the rearward set of pinions, and of course that meshes with the rear portion of the ring gear assembly. So that's going to change the rate of spin on this planetary carrier in relationship to the ring gear, which of course is part of the output shaft assembly. And when we measure gear ratio, what are we really measuring? We're measuring the speed of the output shaft against the speed of the engine. So in 3rd gear, for every 1.5 times the engine rotates, you get 1 output shaft rotation, one complete rotation of the output shaft for every 1.5 rotations of the engine. So we are saying that this output shaft is underdriving the engine. Okay, so gears 1, 2, 3, and 4 are all underdrive gears, meaning the output shaft is spinning at a rate less than that of the engine. In gears 5 and 6, the output shaft is overdriving the engine, meaning it is spinning faster than engine rotation. So in the case of 5th gear, you have 0.85 engine rotations for every 1 output shaft rotation. 6th gear is 0.67 to 1. So that's how you interpret the differential rates of rotation and how they're associated with your gear ratios in your forward pattern shift strategy. Okay, so with that said, we have one more hub that we have to incorporate here into this delivery chain, and that is the 3.5R hub. So let me see if I can spline this in. Okay, it's got, I don't know, 2 or 3 frictions. That's good enough. So now we're going to go ahead and we're going to carefully join our planet with our hubs. I said carefully. I thought I meant it, but maybe not. Okay. And then we're going to omit the center support here and the sprag because they really don't figure in, but know that obviously you'd have a center support, you'd have your low reverse clutch, and you would have your 2.6 clutch. And if we were, if the scenario involved any of those applied elements, then we would put that in here. But it doesn't, and I'm just going to leave this like this for now. So the key takeaway here is that when you have a slip in 3rd gear, the 3.5R clutch hub is uncontrollably changing its rate of rotation, which has a domino effect on the sun gear, the planet, and the ring gear that it's splined to, and consequently that is rapidly and uncontrollably changing the rate of rotation of the output shaft. And that is why it feels like you're slipping, because that's exactly what's happening. Okay, slip is simply an uncontrolled sudden change in gear ratio from one otherwise stable state to an unstable state. So in a nutshell, that is the mechanics behind failure of an applied element in an automatic transmission, in this case a 6L transmission. So when you have skeletal failure, let's just say, I don't know, planetary or gear train failure, that often results in no movement. Okay, we went over that example a few minutes ago with the input planetary assembly. And then, you may also, in very high performance, heavy duty applications or situations where a vehicle is being abused or fluid is low, you may have a failure of one of these shafts, the input shaft or output shaft. And that, of course, will result in no movement. One of the more common problems with these things in any kind of performance situation is failure of the 4.5/6 clutch hub. So I liken that to the quote-unquote intermediate shaft. I mean, to me, that's what it is. Let me get this planet out of the way. And we'll talk a little bit about that as kind of a bonus. Get these 2 hubs. All right. So here is your 4.5/6 clutch hub. Okay, this hub loves to snap in this area right here. And so you'll have your shaft spinning independently of the hub itself. When that occurs, you will lose 4, 5, and 6. So no 4th, no 5th, no 6th gear. If that happens to you, and especially if you have done engine mods and you like to drive the vehicle as if it had engine mods, you can almost guarantee that this is the cause of your problem, even before the 4.5/6 clutch itself. Now the 4.5/6 clutch is very vulnerable to overheating. So if you have a 4.5/6 clutch that is slipping or failing and your transmission consistently runs over 200 plus degrees, then more than likely that is the root cause behind the failure of your 4.5/6 clutch. And we see this more in the later model units, or the units that came with those cooler bypass valves that were set to regulate at 90 degrees Celsius or 195 degrees Fahrenheit. The updated cooler bypass valves that GM makes are set to regulate at 158 degrees Fahrenheit or 70 Celsius, and you can just look on the body or the housing of the bypass valve, and if you see a 70 stamped into the housing, you know you have the updated version. If you see a 90, then you want to change that to a 70 or just install a delete kit or flip the pill. And I'll do a separate video on that at another time, but suffice to say, the 456 clutch, again another example, fibrous muscle tissue, is the most vulnerable when it comes to transmission temperatures and temps exceeding, say 180 degrees. I like temperatures to be no higher than that on a sustained basis. Even with the Deck 6 full synthetic fluid, it's, maybe I'm just old school, but that's where I like to keep the transmission's temperature at all times. Max 180, and then I think there's like a floor, and it's almost nothing you have to worry about unless you live like in Alaska or some other really, really cold weather place. Then you actually may want to run that 90 degree thermostat or cooler bypass valve if the vehicle's so equipped. You may not want to swap to the updated one. All right, so that is part one of transmission diagnosis and troubleshooting fundamentals. We talked through the anatomy of a transmission, its theory and concept of operations. We introduced you to the range reference chart and showed you how to use it and walked through a couple of scenarios. And so you should have a good foundational understanding of how a transmission works. Assuming that you knew very little, if anything, before this video, you now have a very good understanding compared to most people that haven't seen this video. So, and don't otherwise know how a transmission functions and all the dynamics and theory involved. The next several videos are going to be more focused and more technical in nature. We're going to be doing some bench testing. We're going to be doing some vacuum testing of the valve body. We're going to show you how to service the TECM, bench test the internal mode switch, and we will get into deep detail about how to diagnose and troubleshoot problems. Unlike in this video, we will bring in the valve body and we will talk in detail about all of the areas within the valve body that should be considered and how to test or inspect those portions so that you can rule that in or out. Okay, so as always, thank you so much for watching. I really appreciate all your viewership and your time, your subscribership, if you're in fact subscribed. If not, please do so. I'll be putting out a lot more videos on the 6L family of transmissions, including the rest of the diagnostic and troubleshooting series, so there's that to look forward to. And then we'll also be doing some other GM stuff in the coming weeks and months. So as always, have a great rest of your day or evening, and I look forward to seeing you on part 2.